Hello, everyone. My name is Brad Kamarmi. I worked with Raed Alham on this project, and this is the ISE 5110 design of experiment that we worked on. Oops. Our problem statement was we were trying to optimize the tolerance levels in the MTCAT machine to improve quality and potentially save money in manufacturing costs. The machine is designed to put a male high pressure connection on heavy walled stainless steel seamless tubing. For the literature review, I listed some of the references we used here. What was very interesting to me is, I thought this situation was somewhat unique, and it was not. A lot of people have looked at this, and Anselm Lorenzi had some really good insights, and he referenced the ISO standards, and he said the standard is designed to allow the ability to interchange mass-produced parts and the inherent inaccuracy of the manufacturing methods. The exactness of size has found to be unnecessary for most features of a component and can be manufactured so the component features fit within two allowable limits, i.e. a tolerance. And that's really what this project is all about, is optimizing those tolerances. Milberg also had some very interesting insights on costs associated with the ISO standards. And he said, he assumes that the accuracy of a component does not have a linear, but rather an exponential effect on the production costs. The final reference there I had is on the nature of running in, and when it's kind of related to some of the future studies, so I included it there. Here you can see the factors and levels. I showed a picture of the machine setup to kind of show how they all stack up there. And what we're trying to do is we're trying to minimize the final quality result on the tube and the final concentricity reading. So I call out all the different parts that we used as variables, and then you can see their levels below here. On the next page, you can see the experimental plan and the results that we came up with. We came up with a 16-run design of experiment. And in the far right column, we had the quality control people record the concentricity of the final tube here in inches. So this result here is the final acceptance criteria of the machine. And then here you can see the different levels of our factors. And what we did is we measured these parts on a CMM and then staged them to build with the specific parts on a specific machine. Next, we go to the results and analysis. The only one we really determined was a significant factor was the machine version, either the 1 inch or the 1.5 inches. That was very surprising to me. I expected there to be a lot more findings here. We did show that some of the other factors had a slight effect, but nothing really major. The other thing that was very surprising to me is I expected a lot more interaction between the parts, and we just didn't see that. Lastly, that leads us to the implications, and basically it gave us direction on further studies. We kind of ruled out some things, and we really need to look at the differences between the 1 inch and the 1.5 inch machine versions, the collet speed, the spindle speed, and the motor. Thank you.